Hello everyone, my name is Dr. Arvind. Now we are going to perform one of the Dbms lab experiment that is from part B, experiment number 4. So I would like to show you that experiment. I hope it is visible. So here, so this is the experiment number 4 from part B. So now we have to create a college database. So in that we need to create these many tables related to the college database, like student, semester, section, then class, subject, and IA marks. That is internal assessment marks. Now, I would like to show you the schema diagram for this college database for better understanding, so that you will be able to understand what type of relationship you have to establish in between the columns of those tables. So this is the schema diagram for that college database. So these many tables we need to create: student, semester section, then class, subject, IA marks. Okay. So in this schema diagram, this rectangle, if you consider this student table, so these are the blocks, different blocks. Each block represents one column. If it's underlined, which means that column is primary key column. So similarly, for this table, SSID is the primary key column. In this class table, USN and both, that is SSID, both are the primary key columns. And for subject, subject code is the primary key column. And for the IA marks, USN and subject code are the and as well as SSID as the primary key column. No, uh, now here you can see some outgoing arrows are there. So what is the meaning of that? If outgoing arrows are there, means there is a foreign key. Okay, for example, incoming arrows and outgoing arrows are there. If incoming arrows are there, means that table is treated as a master table. So for example, for the student table, some incoming arrows, which means the student table as a master table. For whom? From these, from where this arrow is coming? From class. So class is the slave table for student. Again, one more arrow is coming from IA marks. So what is IA marks here? IA marks is the slave table, or we call it as a child table. Okay. So this is about incoming arrows. What about outgoing arrows? So in this student table, no outgoing arrows. Then in this class, there are two outgoing arrows. What is that? For USN, there is outgoing arrows towards same sec or semester section. Okay. So what is the meaning of this? If outgoing arrow is there, which means that particular column is a foreign key column. So this USN is a foreign key column, which means that column will refer the values of, this is not going towards semester section. This is going towards the student. If you look at properly, it is going like this. So which means here is also USN and here is also USN. What is the difference between them? So this USN is treated as foreign key column and this USN is treated as primary key of the master table. So just remember one thing, foreign key is always present in the slave table. Similarly for SSID, this one is a foreign key and this arrow is going, outgoing arrows towards semester section. So which means here is also SSID and here is also SSID, which means this SSID is the foreign key. and this SSID will become as a primary key for this master table. So what is the meaning of this foreign key? Now you understood, if outgoing arrow is there, that is a foreign key. But what is the use of that? Means what are the values are there in the master table of the primary key? Only those values we can insert here. Which means foreign key column will refer the values of primary key of the master table. Refer in the sense only those values we can insert. I hope you understood this concept, foreign key and primary key, master and slave table. So similarly, three arrows, outgoing arrows are here: USN, subject code, and SSID. So like this, we'll discuss how to create the tables by applying appropriate constraints. So first we need to create the student table. So this is the syntax for or code for the student table. So how many columns are there? USN, student name, address, phone number, and gender. Simply we need to write that create command, create table name. Then USN. So where we have to apply the primary key? On USN. So simply after that column, we need to write primary. And remaining columns are as it is, which means normal columns. Then come to the second table, semester section. How many columns are there? 3. And one of the column is primary key column, SSID. So we are applying primary key on that. This SSID. Remaining column are normal columns. Next, any outgoing arrows there? No. So no need to create any foreign key. Here come to the class. So here in this, especially in this class table, there are outgoing arrows. We need to apply primary key also and foreign key also. We cannot apply primary key individually in one table, that is multiple primary keys. We can apply combinedly. USN and SSID here. Come to this class. First, we need to create all these columns. USN, SSID, only 2 columns are there. Then we are applying primary key on USN and SSID combinedly. As we discussed, we cannot apply primary key individually in a single table. It's multiple primary keys. We can apply only one primary key on multiple columns combinedly. Then come to the outgoing arrows. If outgoing arrows are there, then we need to apply the foreign key on that particular column. So for USN, there is outgoing arrow. So for this, we need to create foreign key column. So this is the foreign key. On which column we are going to apply foreign key constraint? On USN of this class table. So that USN will refer. That's why we are using this keyword references. To whom? Which is the master table? Student. And this is the primary key of that master table, student USN. See this arrow? This USN arrow is going towards USN of this student. That's why we are writing here. References student USN. Similarly for another column, SSID. So this will be the foreign key and this will refer the values of this table. That is SSID column of this table. That's why we need to write foreign key SSID references semester section of this value. Just look at here. Here is also ESN and here is also ESN. This ESN is belonging to the current table, means class table. This ESN is belonging to the student table. So this one is the slave table and this one is the master table. Here is also, this one is the slave table, that is class, slave table, foreign key, and this is the master table, primary key. Like this, you have to apply the foreign key if any outgoing arrows are there. Next, come to the subject. We need to create the columns like this: subject code, title, semester, credits. Subject code, title, semester, credits. Now underline is there means we need to apply primary key on this subject code. That's it. No outgoing arrows for this subject table. So no need to apply foreign key constraint. Come to the IA marks. So for these three columns, combinedly we will apply primary key. It is IA marks. First, we need to create the columns USN, subject code, SSID, then test 1, test 2, test 3, and final IA marks. Then, after all these columns, where we have to apply the primary key? On this column here, USN, subject code, SSID. Then, three outgoing arrows are there: USN, subject code, and SSID. So, according to this previous means this table, we need to apply foreign key. Same foreign key on USN will refer the values of USN of the student. Again, foreign key. What is foreign key? Subject code will refer the values of subject. That is subject code of subject table. That is master table. Similarly, for SSID will refer the values of SSID of the semester section. So this is according to the schema diagram only. Nothing special. So according to this, you need to create the tables by applying appropriate constraint. So what is new thing is here? That is primary key constraint and foreign key constraint. Let's now discuss. So I have already created these tables and I have already inserted some values. So I would like to show those tables according to their values. For this, what you have to do? You have to use your Oracle. So I have already logged in into the Oracle. For this, how to extract the data or how to retrieve the data from that particular table. So first we need to extract the data from this student table. How to extract? Select star from student. So this is the data for student. Then the next table, same section. Here in the student table, USN, then student name, address, phone number, and its gender. Whereas in semester section, what is there? Then in the first column, student section ID. That is which section? CSC 8 semester A, like that. A, B, C for each semester. Okay, that semester separately is also there. 8 semester and respective sections. Then come to the next table. Class. Select star from class. So what are the details are there in the class? USN and respective SSID, student section ID. Okay, so for that particular USN, it belongs to which SSID or which class. Okay, so that information is there in this table. That's why it is mentioned as class. Then subject. What are the subjects are available? Select star from subject. So these are the subjects are available according to their subject codes. Subject code, subject title, then semester. That particular subject is belonging to which semester and how many credits for that. Then IA marks. Select star from IA marks. This information is there for that particular student, and what is the subject code, and that particular student belonging to which section or section ID, and what is the score in test 1, test 2, test 3. So here in the query we need we'll find out what is the final IA. So that's why it is blank. We'll find out that. So these are the details of all these tables. Now, based on this, we need to execute the given queries according to the question. Here, insert at least 5 records for each table and add appropriate database constraints. So this is already done. Now, what is the first query? List all the student details studying in 4th semester in section C. So we want all the student details, their USN, their name. Okay. Those who are belonging to the 4th semester section C. Section C. We take manually the student table. Not student table, in the class table. Okay. So these are the students belonging to the respective section IDs. Okay. So see here, any 4th semester 6 section is there, one student is there. Okay. That is USN 091, 15 CS 091. So for this student, we want data. So how we'll get? You need to write query like this. Here. So what is that query? Select S dot star. We want all the details. What is this S, SS, SS? These are the shortcut name for that particular table. We call it as alias name. Okay. Instead of writing entire table name, we can use the shortcut name. That's why we are using this shortcut name. So what is S? S represents student. So we are accessing all the details from student table. Then SS means who is representing SS for which table? That is semester section. Then this C is represented for class. So that one we are using in the next slide. So we want to retrieve these data from these many tables. Based on which condition? Because our query is like this only. Based on our query, we need to write a SQL statement. We want the student details studying in 4th semester section C. So first we need to identify what are the sections. Okay. So that's why we are collecting this data from 3 different tables. Because in only one student table, that data is not available. See here, student table, where is the section? Nothing is there. So from student, we'll get student data. From semester section, we'll get the semester and its section also. Okay. So we want 4th semester C. This one. And from this class, we'll get that respect to students. Students in the sense USN, their USN. Those who are belonging to the section 4C. So that's why we need these 3 tables. Here. Student, semester section and class. Now we are applying some condition. If the USN is matching from this student table and class, as well as we are using AND. First, we will discuss this. S dot USN is equal to C dot USN. S in the sense the student, this table. From this table, if any students are common in this class, that data will collect first. Okay. Some students will be common. Next. Again, AND is there. And SSID, this SS dot SSID is equal to C dot SSID. And so what is this? SS means semester section and C means class. So from this table, semester section and class, if that what is that condition? Let's check once again. SSID, that student, not student, semester section ID is matching. Some sections are matching with this. So from that, what will take? SS dot semester. Which semester will take? For semester. And section will which semester? Sorry, which section will select here? C. So we are having only one record. Those who are belonging to this fourth semester. C. Where is that? This one. I want the details of this USN. That's why we are getting the details. This USN is matching. If you execute this, we'll get these details. That's why we're getting these Santosh details. This is query number 1. Next. What is query number 2? Compute the total number of male and female students in each semester and each section. Means we want total number, means count we want. How many females in each semester and each section. Okay. So we need to make it as group, means semester wise as well as section wise. And in that, how many males and how many female students are there? So for this, what we have to use? We have to use group by clause. First, I will execute this here. We are getting the count for the respective semester and section. This is the gender here. For this, we need 3 tables data: SS, S, and class. Okay. Semester, section, gender, and what is the count? From student, semester, section, and class. If USN is matching and SSID is matching, then we are grouping that, because whenever each word is coming, each semester and each section, then we should use the group by clause on that particular columns. Semester wise and section wise, we need to group by. We need to apply the group by clause. Semester wise and section wise. And what is the gender? And we are sorting by the semester here. Now in the result you check the third semester, third semester, these many sections A, B, C. So it is semester wise as well as section wise. So in third semester A section, what is the gender? Male. How many males? Only one male. Why there is no female? Means why female data is not coming? Because there is no female in that particular third semester section A. That's why that data is not coming. If it is there, definitely it will come. I will show you on one example here. Here, 3B, only female is there. Male is not there. That's why it is not coming. In 3C, only male is there. Now see here. Especially in 4A, female is also there, one female, and one male is also there. Then for fourth semester B, male. So according to this, we'll get the male female count for each section and each semester. Come to the third query. Create a view of test 1, marks of students, USN, this one. Now we need to create a view. So what is view? View is a logical entity for a table. Table is physical existence. So based on that existing table, we can create our logical view for this USN. How to write that? Like this. Name is already used by an existing object. That particular view is already created. Now we will do one thing. We'll drop that view. There is a command called drop view name. Now we can create. Either we can give another name or can drop and again create. Now view is created. So what is the syntax? Create view name. You can give any view name. So view is always dependent on the table. So for that, we should write the select command. Okay, create view name as select statement. In the select statement, we are giving the table name based on this IS marks. Remember one thing, views are always dependent on the tables. Without table, we cannot create the views. So in the query itself, we need to create the views for test marks for this particular USN. That's why it depends on this IA marks table. So in the condition, we can view where USN is equal to that. This one. View is created. Next, fourth one, calculate the final IA. So you can see in the IA marks table, final IA marks column is blank. So now we'll create one procedure in the sense some automatic function in PL/SQL language. Okay, procedure language for SQL. So it is like a programming language. So that it will automatically calculate the uh, average of based of two test marks out of three. Then it will calculate the average. For example, 15, 16, 18 for this particular student. What is best of two tests? 16 and 18. Okay, 15 is less. So it will calculate the average of this best of two tests in and 18. That value will come here. And update the corresponding table for all the students. So it should reflect to all the students. we discussed, we need to create a procedure for this. It is created. Just look at this code. So this is the syntax: create or replace procedure average marks. Because we are calculating the average marks. Is cursor. So we are creating a cursor here in the procedure. On what basis? Select greatest. So we are taking the base two test marks. That's why we are using the greatest. So test 1 and test 2 as A. Again, we are checking all this combination. Test 1 is test 1, test 2, then test 1, test 3, and test 3 and test 2. Whichever is best 2, that one will consider from this IA marks. Where final mark is null, now it is null, then we are creating these variables to store the values. Now we'll apply some logic in this. So it will execute up to the end of the records. So that procedure is created, that ready-made function is created. Now, if I execute this procedure, some related to space error is there in the average marks. And number 26. We'll change this size or this final I. For this, we need to apply the alter command. Modify final I number bracket 2. Now that procedure is created successfully because that size was not sufficient. So we have changed the size as 2. It will take the approximate, not approximate, exact value. Means integer value, not decimal value. Now our PLSQL procedure is created successfully. Now if we access that particular IA marks table, we will get final marks. Just now we discussed. Previously that column was blank. Now after creating a procedure, we are getting the, because that code is there. It will take the best of 2 marks, 2 test marks, and it will calculate the average. 16 plus 18 divided by 2. So we are getting the best of 2 test average for all the students. Next, last, categorize students based on the following criteria. Some criteria is there for the final IA. Final IA marks means just now we have created this final IA marks. That range is from 17 to 20, then category should be outstanding. If IA marks category is 12 to 16, then category should be average. If IA marks is less than 12, then category should be weak. So like this, you have to display the data. So give these details only for 8 semester students for ABC sectors, not for all the semesters. For this, what you will do? So this is the query. Based on these same IA marks. So this 17 is coming in which category? We are given some different, okay? 17 to 20, outstanding. Okay, we are using some cases here. Okay, PLSQL code is there. Okay, select USN, name, address, phone number, gender. Here, select USN, name, address, phone number, gender. So this is the case. When IA final marks is between 17 to 20, then outstanding. Okay. So for this, it is outstanding because it is the range for this outstanding. If it is 15, then it is average. If it is below 12, then it is. But we don't have such type of marks here. 12 and 16, not 12 and 16, below 12. That's why we are not getting any weak. So one more condition is there. We want the details of only 8 semester students. So these are the 8 semester students only. So like this, you have to perform these queries. I hope you understood all these things. Thank you very much. We'll stop here.